walking into a sports supplement store or, like, the lobby of a big commercial gym can be an intensely overwhelming experience.
Oh, absolutely. It's sensory overload.
Right. If you've ever done it, you know the exact drill. You're immediately hit with this wall of aggressive marketing. Neon labels, holographic fonts, pictures of impossibly shredded people.
Yeah, it's a very specific aesthetic.
And inevitably, right there in the center of the aisle, commanding massive amounts of shelf space, you're going to see these giant, industrial-looking tubs of white powder.
Usually adorned with names that sound like military operations or apocalyptic events.
Exactly, like cellular annihilation or anabolic explosion, all of that. But for decades, one single substance has absolutely dominated the conversation in those aisles and in locker rooms all around the world: creatine.
Yeah, creatine. It's everywhere.
We tend to think of it as this incredibly niche, hardcore gym bro substance. But the sources we are looking at today suggest something wildly different.
Wildly different, yeah.
I mean, what if that tub of white powder isn't just for 22-year-olds trying to bench press a small car? What if it's actually a fundamentally essential daily nutrient for, say, fetal development during pregnancy?
Or for combating depression in women.
Right. Or protecting the aging brain against neurodegeneration.
It is arguably the most fascinating paradox in modern nutritional science. I mean, you have a compound that has been studied in hundreds upon hundreds of clinical trials.
It's literally the most researched human performance supplement in history.
Right. Yet the average person walking down the street still associates it with kidney failure, hair loss, and illegal doping.
Which brings us to the mission of today's deep dive. We are going to take a scalpel to this topic. So if you are listening to this and you've never touched a barbell in your life, stick with us.
Because the implications here go way, way beyond the weight room.
Exactly. We are going to separate the cold, hard physiological facts from the deeply entrenched locker room mythology. And we aren't pulling from, random fitness blogs here.
No, not at all.
We are diving into a massive, internationally renowned 2021 scientific review. It was published in the Journal of the International Society of Sports Nutrition, or the ISSN.
And it's really an unprecedented piece of literature in its scope. What this team of internationally renowned researchers did was consolidate data from over 500 peer-reviewed publications.
500? That's a mountain of data.
It is. They brought together a panel of experts who have collectively published over 200 standalone papers just on creatine kinetics and metabolism alone.
Wow.
Yeah, and they did this specifically to definitively answer 12 pervasive, stubborn questions and misconceptions that just refuse to die in the public consciousness.
And to help synthesize this absolute mountain of data, I have our resident expert here. So let's jump right in. Before we start busting medical myths, we need to establish a chemical baseline. What actually is this substance?
That's a great place to start.
Because the way the media and gym culture talk about it, you'd think it was cooked up in a subterranean laboratory by a mad scientist.
Yeah, the whole Franken drug narrative is incredibly persistent. But the biological reality is profoundly less sinister.
Okay, so what is it?
Creatine is not an artificial chemical invention. It is a naturally occurring nitrogenous organic acid. Chemically, its proper name is methylguanidine acetic acid.
Okay, methylguanidine acetic acid.
Right. And your body is actually manufacturing it right now.
Wait, my own organs are producing the exact same compound that is sold in those massive tubs.
The very same molecule. It is endogenously formed, which just means it's created inside your own system.
Where exactly?
Primarily in your kidneys and your liver, with a really small amount synthesized in the pancreas. Your body builds it by combining 3 basic everyday amino acids.
Which ones?
Arginine, glycine, and methionine. So your internal organs are basically a continuous creatine factory. You're producing about 1 to 2 grams of it every single day.
Okay, so we are building it internally, but we also consume it through food, right?
Yeah.
Assuming we aren't eating a purely plant-based diet.
Yeah, we do. We consume it exogenously. It's highly concentrated in skeletal muscle, which means it is found naturally in meat and fish.
So like a steak.
Exactly. If you eat a steak, a pork chop, or a salmon fillet, you are consuming dietary creatine.
Okay, let's unpack this. We have a compound synthesized from standard amino acids, produced round the clock by our liver and kidneys, and found in a regular Tuesday night hamburger.
That's the reality of it, yeah.
If it is that deeply integrated into baseline human biology, we have to figure out why the societal whispering around it is so intense and fearful.
It is really quite strange when you step back and look at it.
The most prominent rumors, the hurdle that stops so many people, especially parents of young athletes, from even considering it, is that it is simply a legal loophole, like a legal steroid.
Yeah. That rumor is the foundation of almost all the other fears. People conflate the physical results of resistance training while using creatine with the actual physiological mechanism of anabolics.
Let's break down the biological and legal walls between the two because they clearly aren't the same thing.
Not even close.
I mean, I know steroids are heavily regulated, but functionally, if they both help build muscle, what is the actual dividing line at the cellular level?
The dividing line is basically the difference between hormonal manipulation and bioenergetic support. Anabolic steroids are synthetic drugs.
Okay.
Specifically, they are exogenous versions of testosterone or related androgenic hormones.
Right.
When someone injects or ingests an anabolic steroid, that synthetic hormone enters the bloodstream, permeates the lipid bilayer of the muscle cell, and actually binds to an intracellular androgen receptor.
And what happens when it binds?
Once it binds, that steroid receptor complex physically enters the nucleus of the cell and alters gene expression. It forces an unnatural increase in muscle protein synthesis.
Wow.
Yeah, it is a systemic hormonal override of your body's natural genetic limits.
So it's essentially hacking the cell's blueprint to force it to build more tissue, regardless of the biological cost.
Exactly.
And because of that systemic override, the legal boundaries are massive.
Oh, massive. Because the physiological impacts and risks to the endocrine system, the heart, and the liver are so severe, anabolic steroids are Class C, Schedule 3 controlled substances in the United States.
So they're treated as serious drugs.
Absolutely. They are heavily regulated by the Drug Enforcement Administration under the Controlled Substances Act. Distributing them without a specific, tightly controlled medical prescription is literally a federal crime.
So where does creatine fall in the eyes of the regulatory bodies?
Creatine is overseen by the Food and Drug Administration under the Dietary Supplement Health and Education Act of 1994, commonly known as DSHEA.
Okay, so it's a supplement.
Right. It is legally categorized as a dietary supplement. In the eyes of the law, it is no different than a vitamin C tablet or a fish oil capsule.
Okay, the legal distinction is clear,
Yeah.
but I want to push on the mechanism a bit.
Yeah.
You mentioned steroids alter gene expression.
Yes.
If creatine isn't hacking the nucleus and changing our hormones, how is it actually creating the physical changes people see? Because people taking it get demonstrably stronger and faster.
They do. And this is where we have to look at cellular bioenergetics. Creatine doesn't tell the muscle to grow. It acts as a localized energy reserve.
An energy reserve, how does that work?
To understand how it does that, we have to look at the phosphocreatine, or PCR, system within the cell.
Okay, we all know ATP, adenosine triphosphate, is the baseline energy currency of the cell. It's what our mitochondria produce.
Right.
But how does this specific compound, creatine, intervene in that established energy cycle?
So when your muscle undergoes intense, brief anaerobic contraction, like sprinting all out or lifting a heavy barbell, it burns through its immediately available ATP incredibly fast.
Like how fast?
Usually in just a few seconds. The cell uses ATP by snapping off one of its 3 phosphate molecules. That breaking of the chemical bond releases the energy needed for the muscle to contract.
Right.
But once that phosphate is snapped off, the ATP becomes ADP adenosine diphosphate. It only has 2 phosphates now.
So it's essentially a dead battery. It has to be recharged back to ATP before the muscle can use it again.
Precisely. Now, the cell has multiple ways to recharge that battery, like using glucose or fat, but those processes take time.
Which you don't have if you're sprinting.
Exactly.
Hey.
If you are in the middle of a heavy squat or a 100-meter sprint, you don't have time. You need ATP regenerated instantaneously. This is the sole job of the phosphocreatine system. The creatine you naturally produce, or that you ingest, is stored in your muscle tissue attached to a phosphate molecule. We call it phosphocreatine.
So it's basically walking around the cell holding on to a spare part.
Essentially, yes. When ATP levels drop and ADP levels rise, an enzyme called creatine kinase springs into action.
And what does the enzyme do?
It strips the phosphate off the stored phosphocreatine and rapidly donates it to the dead ADP, instantly turning it back into functional ATP.
Okay, I think I get it. So if ATP is our checking account, like the money we have on hand to spend right this second, creatine is basically a high-yield savings account. When the checking account hits 0 in the middle of a sprint, we instantly transfer funds from the creatine savings account to keep the muscle firing.
That is a perfect way to visualize it. It is an energy buffer It doesn't build muscle directly.
It just gives you more fuel.
Exactly. What it does is allow you to maintain peak power output for a few critical seconds longer. It gives the weightlifter the cellular energy to get 2 more repetitions.
Right.
It gives the sprinter the fuel to maintain top speed for a few more meters before fatigue inevitably sets in.
But the casual observer just sees the end result. They see a guy in the gym lifting heavier weights and putting on more muscle mass over a 6-month period, and they just assume he's manipulating his hormones.
Exactly. The visible outcomes overlap, but the pathways are entirely distinct. Steroids build muscle passively by forcing protein synthesis,
While creatine requires you to do the actual work.
right?
Creatine merely provides the raw cellular energy required for you to train harder, accumulate more mechanical tension, and recover faster between sets. You still have to subject the muscle to the physical work. You are just giving the cellular engine a larger temporary fuel tank to draw from.
Well, that definitely puts the steroid myth to bed entirely. It's not a hormone, it's not illegal, and it's basically just a backup battery for short-term energy.
Correct.
But as we move from the locker room to the doctor's office, we encounter a much more clinical fear. If it's just an energy buffer, why is there a pervasive belief that it destroys your vital organs?
Yeah, the kidney myth.
Right. This brings us to the most stubborn medical mythology surrounding this topic. The idea that creatine systematically destroys your kidneys.
In the realm of sports nutrition, the fear of renal failure is perhaps second only to the myth that high-protein diets destroy healthy kidneys.
Yeah, that's another big one. And it is incredibly frustrating for researchers because, despite over 20 years of continuous data proving there are no adverse renal effects from recommended doses in healthy populations.
You still believe it?
Yes. The fear remains a baseline assumption for many general practitioners, even today.
We have to trace the epidemiology of this rumor. There has to be a patient zero for this level of specific medical panic. It couldn't have just materialized out of thin air.
It didn't. We can trace the entire origin of this widespread global panic back to a single highly publicized case study, just one.
Just one.
Yeah. It was published in the prestigious medical journal The Lancet in 1998, authored by a pair of physicians, Pritchard and Kalra.
One case study from the late 90s triggered a quarter century of medical anxiety. That's wild. I want to look very closely at the methodology of this case. Who was the patient they were observing?
The patient was a young male. And this is the crucial context that is almost always omitted when this study is cited. He was not a healthy baseline individual who suddenly developed kidney pathology after taking a supplement.
Wait, he wasn't healthy to begin with.
No. This patient had already been suffering from a highly severe pre-existing kidney disease called focal segmental glomerulosclerosis for 8 solid years prior to the study.
8 years of severely compromised kidney function. I mean, that is a massive confounding variable.
Oh, it gets much more complicated. Because of the severity of his condition, he had been medically managed with a drug called cyclosporine for 5 years.
What is cyclosporine?
It's a powerful immunosuppressant used to prevent organ rejection and treat severe autoimmune diseases. But its most well-known side effect is that it is highly nephrotoxic. It is clinically known to cause structural damage to the kidneys over time.
Wait, so the physicians had a patient with a near decade-long history of a deteriorating kidney disease who was actively taking a drug known to destroy kidney tissue.
Yes.
How did creatine even enter the narrative?
The young man decided on his own to start taking an over-the-counter creatine supplement to help with his physical conditioning. According to the case report, he took a loading dose of 15 grams a day for a week and then dropped down to a maintenance dose of 2 grams a day for 7 weeks.
And what happened?
During a routine checkup, the doctors monitoring him took a blood test, looked at one specific biomarker, and concluded his kidney function was rapidly deteriorating. They told him to immediately cease taking the creatine. They wrote up the case, and The Lancet published it.
What was the specific biomarker they looked at? What was the smoking gun?
They looked at his blood serum levels of a molecule called creatinine.
Creatinine, with the N at the end.
Yes, exactly. And understanding the biochemical relationship between creatinine the supplement and creatinine the biomarker is the key to unraveling this entire medical error.
Break down that pathway for me. I know creatinine is a waste product, but
Sure.
How do we get from A to B?
When your muscles use stored phosphocreatine for energy, a small percentage of it naturally degrades over time. It undergoes a non-enzymatic spontaneous degradation, and it turns into a metabolic byproduct called creatinine. Think of it as the inevitable exhaust fumes from a cellular engine.
That makes sense.
Now, in a functioning human body, this creatinine byproduct diffuses out of the muscle cell, enters the systemic bloodstream, and travels to the kidneys. The kidneys act as a filtration system. They filter the creatinine out of the blood and excrete it into your urine.
So the kidneys are basically the waste management facility clearing out the exhaust.
Correct. And because healthy kidneys filter creatinine out at a relatively steady, predictable rate, nephrologists have historically used the concentration of creatinine in your blood as a proxy marker for your glomerular filtration rate, or GFR.
Which is essentially a measure of how well your kidneys are filtering.
Exactly. The logic is simple. If your blood creatinine levels suddenly spike, it implies your kidneys are failing to filter the blood efficiently.
I follow the logic, but there seems to be a glaring hole here if the patient is actively supplementing. I mean, if you put more fuel in the engine, wouldn't you naturally produce more exhaust?
And that is the massive flaw in their assumption. The baseline amount of creatinine in your blood is directly proportional to two things: your total skeletal muscle mass, which is why men typically have higher baseline levels than women, and your dietary intake of creatine. If you eat a massive steak dinner, your blood creatinine levels will temporarily rise. And if you take a pure concentrated creatine supplement every day, your blood and urinary creatinine levels will absolutely skyrocket.
Because the system is processing a larger volume of raw material, not because the filter is broken.
Precisely. You are putting more of the precursor molecule into the muscle, so the muscle inevitably produces more of the harmless byproduct.
Okay, wow.
An elevation in serum creatinine in someone taking creatine does not indicate renal pathology. It merely indicates that the supplement is successfully saturating the muscle tissue. The filter is working perfectly fine. There is simply more total volume moving through it.
So these physicians looked at a proxy marker for kidney function, saw it elevate, and blamed the supplement, entirely missing the fact that the supplement itself is the direct, harmless cause of that specific marker's elevation.
That's exactly what happened.
Did the broader medical community not catch this at the time?
Oh, the experts in the field caught it immediately. Within weeks of that 1998 case report being published, two separate teams of leading researchers in muscle bioenergetics wrote formal letters to the editor of The Lancet.
To point out the error?
Yes.
Yeah.
They rigorously pointed out this exact metabolic flaw. They also pointed out that the authors had completely ignored two prior, well-controlled studies that had already demonstrated creatine had no negative impact on renal function.
But I'm guessing the media didn't care about the letters to the editor.
Exactly. As is often the case with medical panics, the initial scary headline received global coverage, and the nuanced biochemical correction was ignored.
The fear always travels faster than the facts. So what has the actual rigorous data shown since 1998? Have we tracked this in healthy populations?
The subsequent data is overwhelming. We now have over a quarter-century of post-marketing surveillance. We have controlled clinical trials lasting months and years.
What do they show?
Think about the sheer scale of use. Millions of athletes, military personnel, and everyday people consuming thousands of tons of this compound annually. If creatine genuinely caused renal toxicity, we would have witnessed an undeniable epidemiological epidemic of kidney failure in young, healthy populations over the last 25 years.
Which we haven't seen.
We haven't. The clinical consensus is unanimous. In healthy individuals making the recommended daily doses, there is zero evidence of kidney damage, renal dysfunction, or alteration of actual kidney filtration rates.
That is a profound relief and a great example of why we can't rely on a single case study with compromised variable.
Absolutely.
So the filtration organs are safe. But what about the fluid itself? If we look at the other major physiological fear, it's the idea that creatine turns you into a bloated, dehydrated water balloon.
Right, the hydration myth.
The prevailing wisdom is that it sucks the water out of your systemic circulation, traps it in your muscles, and leaves you prone to severe muscle cramps and heat stroke.
This is a particularly interesting area to analyze because, unlike the kidney myth, which was based on a flawed biomarker, the dehydration myth is actually rooted in a partial understanding of a genuine physiological mechanism.
Oh, really?
Yeah. The fear was taken so seriously that in the early 2000s, the American College of Sports Medicine, the ACSM, issued a formal advisory warning athletes to avoid using creatine if they were exercising intensely in hot or humid environments.
The ACSM is a massive, highly respected organization. They don't issue warnings lightly. What were they seeing in the early data that spooked them?
They were looking at early reports of rapid weight gain and water retention. It is a biological fact that creatine is a highly osmotically active substance.
I remember osmosis from high school biology. Water moves across